Hello, everyone. Welcome to today's webinar titled Surface Preparation for Tile and Stone. I'm Jim Olson with the National Tile Contractors Association, and I want to welcome you and thank you for taking time out of your busy schedule to attend today's webinar sponsored by MAPEI. Before I introduce today's speaker, I want to remind you that during the webinar, you'll be muted. Please use the questions area on your computer to type in your questions, and we'll answer those at the end of the presentation. If the audio on your computer is poor, call the number on the invite to this webinar and listen on your phone. All NTCA webinars are available to watch at any time on the NTCA YouTube channel shortly after the webinars are presented. This will give you easy access to watch and or share all current or past programs at your convenience. All right, I'm very happy to introduce today's speaker, Jim Whitfield. Jim is a FCSI CCPR LEED AP, and he's the Director of Technical Services at MAPEI. He manages a strong technical services department that provides support for MAPEI's floor covering and tile and stone installation systems. He is actively involved in the development of tile industry standards on TCA board and handbook. He is involved with the ANSI A108 and ISO committees. Jim's also on the NTCA, National Tile Contractors Association Technical Committee. He is the current president of the Materials, Methods, and Standards Association, known as MMSA. In addition, the Construction Specification Institute, CSI, honored Jim for his contributions to education in the construction industry with fellowship in 2001, which is a great honor. Jim, we're welcome. We look forward to Jim. Welcome to you, Jim, and we look forward to this presentation. Thank you.
Thank you, Jim. I appreciate it. Very nice. All right, let's get started. We're going to talk about surface preparation for tile and stone. That's changed a lot the last few years. All right, some of the learning objectives, we'll review substrate tolerances or flatness requirements in our industry documents. Learn how to properly specify surface preparation for all the important finishes. Discuss the different methods and products used in surface preparation. Understand how self-levelers work, and learn the basics of self-leveler applications and primers. And last, learn how to create the proper substrate conditions to increase your mortar coverage and reduce the likelihood of lippage, which will make it a much safer environment on the project. You know, just like your house, you want to have a good foundation underneath it. Surface prep is just that to the tile installation and stone installation. It's all about the prep. The better the prep, the easier it goes. Benjamin Franklin said, by failing to prepare, you are preparing to fail. It's critically important. It's important that you have a good idea how the substrate is, what's underneath the current finishes if you're going to do a remodel. It's important that you understand what it's going to take to get it in good shape for your project. Why is it so important? Well, tiles are getting bigger and bigger and bigger. Now here we show looks like a 1 meter by 3 meter gauge porcelain tile. They're much larger than that even today. Some are 5'6" by 10'6", even larger. So tiles are getting bigger and bigger. Tiles today are no longer just square. Rectangles, planks, things like that are very, very common. The gauge porcelain tiles, some are as thin as 1/8 of an inch. And so they can actually curve or conform, if you might, to regularities. So it's important that everything's be flattened out properly. We're talking about walls as well. We're not just talking about floor prep. We're talking about walls as well. And for productivity, if you want to be productive on a project, get all your surface prep done appropriately first. Planks have made things a little bit different as well because tiles can have up to 1/16 of an inch of warpage in the middle of them. It's common with, especially plank type tiles, the longer they are, that you get a little bit of warpage in them. And now the industry, we made some changes in the ANSI requirements a few years ago that say that you need to offset a running bond by 33%, not 50%. Why? Because the highest part of one tile is the middle of the tile. In other words, if there's warpage, it's typically in the middle of the tile. The flattest part is the edges. So the last thing you want to do is line up the lowest parts of the edges to the middle part of the tile in front of it. It just makes the lippage all that much worse and really, really looks bad. So it's recommended in ANSI that we do a 33% offset. Anything greater than that needs to be approved by mock-up. Well, why is lippage such a big concern? It is by far the largest complaint in installations, whether it's floors, walls, or anywhere. It's just not attractive. What our industry documents say, the TCA reference manual has quite a bit on TCA website as well as in the handbook on lippage. ANSI, as I said, has it in there in the A108.02. And I want to point out something. You know, this talks about how much lippage you can have in the chart in the middle. It also talks about sometimes when lippage might still be a little bit more acceptable. In other words, if you're doing a tile installation and you have to slope to drain, you'll notice here in the caution section in the middle of this page on ANSI, tiles larger than a 6x6 are typically going to show some lippage. In other words, you can't go out and down without showing a little bit of lippage. So the larger the tile, the more likely you're going to have lippage around a drain type cutting. The smaller the tile, the least likely. So just want to point that out. I mean, I think it's important that contractors understand the ANSI and TCA handbook and ANSI standards, if you might, have a lot of positive language in there for the tile contractor. You know, we recognize in committee that there's sometimes that lippage is just going to be hard to fight. And we make sure that that type of language is in there, like this caution section on the ANSI page. All right, what contributes to lippage? Well, a lot of different things. Tile thickness. You know, sometimes we see patterns, and we had some tile come in from a project in Australia. Australia, from an airport, and they were saying that they were having a lot of cracking and etc. They sent us the patterns for the tile. There's 3 different types of tile, 3 different thicknesses. That makes installation very, very difficult. But in general, tile thickness can contribute to lippage. Tile warpage, of course. The size of the edges of the tile. Sometimes we see rectified tile that's been cut out of a larger rectified tile. Let me explain. So you might see you've got a 12 by 24 that was a 24 by 24 with rectified edges. That means if they mechanically cut the edges all the way around that 24 by 24, they beveled the outside of that edge a little bit, just a small amount, and then they came and they cut that in half later for another rectified. So now you got bevel on possibly 3 edges and no bevel in the other. So it's possible you might get some lippage that way. Substrate flatness or substrate tolerance is critically important. You need to meet the industry standards. They're there for a reason. Type of installation, unfortunately, if you mix your mud too wet or too stiff, those tiles are not going to get laid down the same. And just perception. You could have a wall wash in a bathroom where the angle and the amount of light going down the wall is going to highlight every irregular joint in it. The size of the grout joints. Again, if you have different types of tiles in a pattern, you might have variances in the grout joint even. And the reflectance of the surface. The glossier it is, the more it typically shows this. The American Concrete Institute has FF numbers, floor flatness numbers, and commonly architects specify by these. So they can ask that the concrete be prepared to an FF, for instance, of 25. They're not the same as what we do in the tile industry. In our industry, we have 1/8 of an inch and 10 feet as an example for tiles with one edge greater than 15 inches. Well, the FF number, how does that correlate? It really doesn't. The FF numbers are taken within 72 hours of the pour. They're kept away from edges, so they're not measured when it comes to edges like around a column, or it could be the termination of a slab. There's a lot of differences between the concrete industry and how they get their flatness and what we need for the tile industry. So keep that in mind. They're measuring the slab within 72 hours. we're coming back on the job anywhere from 4 weeks later to beyond that, and now we're going to set tile. Do you think that slab's exactly the same as it was the first 72 hours? No, the odds are slim. So totally different animal. But just to kind of give you a little bit of an idea, the FF numbers for 1/4 inch and 10, close to 25, but with tiles larger than 15 inches on one edge, you really need to be up around 50. As I said, they're typically measured within the first 72 hours. Doesn't factor in any curling of the slab because it stays away from edges. So around the expansion joint or a movement joint, you can really have some real curling. The FF numbers can erode by as much as 10 points by the time it's originally done and when the tile installer shows up on the job. Again, look at that again. That makes a big difference. If you're going from 50 to 35 or 45 for that matter, down to 25, it's a big difference. What starts as a 1/4 inch and 10 feet can be a 1/2 inch by the time the installer shows up. Not good. National Tile Contractors published FF numbers and recommendations, again, for tiles larger than 16 inches and with narrow grout joints. If you don't have sufficient steel, proper reinforcement, and so on, you're going to even get more shrinkage. If you get a weak pour, an over-watered pour for that matter, it's going to be 10 times worse. So really have to pay attention to the slab. Get out there, check it out ahead of time before you decide to show up there with tools, and get a good feel for what's going on your project. Again, we're talking about substrate tolerances or flatness. For tiles with all edges shorter than 15 inches, the substrate should not be out of tolerance more than a 1/4 inch and 10 feet or 16 inches, a 16th of an inch in 12 inches, a foot. For tiles larger than 15 inches, it's an 1/8 of an inch in 10, twice the tolerance, a 16th of an inch in 24 inches. That's measured from the highest point in the floor. Some other ANSI language, it's, in my opinion, very favorable to the tile contractors. ANSI A108.02, prior to commencing ceramic tile work, the tile contractor shall inspect surfaces to receive tile and accessories and shall notify the architect, general contractor, and other designated authority in writing of any visually obvious defects or conditions that may prevent a satisfactory tile installation. That's important. Take that step. Make sure that you point out the issues. The other flooring industries, vinyl, if you might, resilient, they're used to having floor prep done automatically on every project they go. Tile industry, for many, many years, we really didn't have to have that much of it. We had mosaic tile commonly going down in a bathroom floor in a commercial installation and wall tile. So we really didn't have a lot of floor prep. But today, with tiles the size that they are, surface prep is critically important. What about wood substrates? What if you're going to go over plywood? Residential as an example. The same substrate tolerances prevail. If it's greater than 15 inches on one edge of the tile, you need to be a 1/4 inch and 10 feet. I'm sorry, I apologize. Greater than 15 inches, it should be an 1/8 of an inch and 10 feet. 16th of an inch and 2. That can be tough when it comes to plywood because you got a lot of exposed edges. So you got to check all those edges, make sure it's not delaminating or substantially weathered. Quite often we get OSB exposed to moisture. Maybe you live where Jim does up there in Minnesota, and they dump off a bunch of joists in the yard, and it sits there in the snow for a few months, and then they bring it in and start putting down their joists. That OSB is kind of like a hydro sponge, if you might, or a sponge that we use in the tile industry. You know, you put that sponge in your bucket of water and it's going to sit there and float on the top. But once you wring it out and let water get in there, you can take it on very easily every time after that. In other words, once OSB gets soaked, it expands and will allow moisture to get into it much, much easier. If it's kept dry, it'll hold up pretty well. But commonly we see more OSB construction these days. I'm in South Florida, no OSB down here. Wider joint spacing, they're going 19.2, 24 inches on center. and less tongue groove plywood for the substrate itself. These all lend themselves to other issues. The NSI, or National Stone Institute, substrate tolerances for thin set installation are 1/8 of an inch and 10 feet. Tolerances for the installed stone is an 1/8 of an inch and 10 feet, or maximum 3/8 of an inch. As I mentioned earlier, it's critically important that we talk about walls as well. The requirements from ANSI are also pertain to walls. With these large format tiles, getting away from 4x4 wall tile, and now, I mean, let's face it, the average tile is a 12 by 24. Your substrate has to be just as good on a wall as it does on a floor. Most manufacturers today make patching materials, if you might, or rendering materials specific to walls because of large format tile. So with a gypsum or cement board, you still need to be within an 1/8 of an inch and 10 if your tile's got one edge greater than 15 inches. Today, with modern building practices, it's not uncommon. We have FHA straps back there. We've got plumbing back there, anchors and so on. So sometimes the walls bow out a little bit. You got to pay good attention to that. Render your walls or patch your walls as well. Most of us have a product specifically for doing that. When I say that, as an example, we have one that is fiber reinforced. It can go from 1/8 of an inch to 1 1/4 inches, all in one. It's made specifically for walls. It'll bond well to gypsum. It'll bond well to cement board. So if you just have to take care of bird baths in a wall, it's an ideal product for that. If you need to float out a whole room, like this gentleman's doing, and this is our patching material, they prefer to do almost like a mud bed, if you might, on all the walls. But this is bonded direct to gypsum. They're just screeding it off between their screed bars. Let's talk about some different ways of trying to address substrate tolerances or flatness of the substrate. You can make it up with thin set. No, you really shouldn't. If it goes against industry standards, manufacturers will not warrant their product for a patching compound, if you might, if it's a thin set. Thin sets are intended to have a tile or something go over them, not to be exposed to the air. So they can be a very weak installation when it's done as well. And more important, you don't want GCs and architects to just say make it up by putting more thin set down. That's costing you money and making your installation much more difficult. If you have the proper preparation done ahead of time, your installation will be 110% easier. Mud bed installation is another way that we address flatness in tile industry. Patching and grinding. Sometimes if it's sporadic irregularity in the slab, you can grind down the high spots and just patch up bird baths. Or for that matter, self-leveling. Self-leveling have really grown for the tile industry. It's been around forever for the other flooring industries, but for the tile industry, it's grown enough that we actually just recently added ANSI standards to the Tile Council, to the ANSI handbook for self-levelers. I'll get into that in a little bit more detail. What happens when you don't prep? Well, this is one of the things we see commonly when they don't want to do proper prep. They do spot bonding, where they just take blobs of mortar and stick it up there and kind of beat it into the tile next to it till they all look fairly level. Problem is it's a weak bond. Thin sets aren't intended to be used that way. They fail commonly, very commonly. It's just a matter of when, not how. Some of these materials will shrink at different thicknesses differently. So in turn, you get all kinds of coverage issues. You can have impact problems, moisture problems. Spot bonding is not the way to go for the tile industry, period. You get a lot of differential and shrinkage because of the different thicknesses. It's bad, it's bad. Again, this is being done because they don't want to do the proper prep. Mud bed, excellent solution. Of course, quite frequently, I see a mud bed installation at a fairly consistent thickness, but it may not be necessarily leveling the job unless it's called out to be leveled. In other words, they got 1 1/4 inch, 1.5 inches everywhere, same thickness, but it's conforming to the substrate below it. It may still not be flat enough. It can be. They certainly have the ability to do it. But again, That's just not as common as what we typically see. Mud beds typically used when we got to create slope to drain and other things, and which excellent for that, where self-levelers and some of those materials just straight out won't do it. So you're looking at, you know, 1.25 inches is a minimum thickness. When you're wire reinforced, I will tell you 1.5 inches is bare minimum, because to get that wire properly buried is very, very difficult. Thickness is less than that, extremely difficult. So you're looking at 1.5 inches to 2 inches if you have to have wire reinforced unbonded mortar bed. But that's another benefit to mud beds and mortar beds, is you can have them unbonded or you can have them bonded, depending on what your substrate is and what your needs are. Today, it's fairly common to have fast setting mortar beds, really primarily for shower pans. I'm not aware of really being used many other places, but they're ideal if you want to go in and create a pre-slope before a pan. You can get in there typically with waterproofing much faster. You can flood test the overall installation much quicker, allow traffic faster. Just add water and go. Substrate preparation for walls, like I said, fast setting render coats or mortar beds, depending on what your needs are. Patching irregularities in cement board, concrete, masonry, drywall. You're really typically looking for a patching material for a wall that you can get a good stroke in, that you can get a flow to large area very easily, an incredible bond, great strengths, variety of different thicknesses. They're out there. Talk to your suppliers. That is one issue though. When distributors are used to carrying these materials for floors like self-levelers, they're not used to carrying them all the time for walls. It took a while when we first came out with our product for the walls for distributors to pick it up. Once the contractors got in their hands, they totally understood it and wanted it right away. But the distributors didn't. They didn't quite get it. So it's important that they keep that in mind. If you're a contractor, you want to have a wall render type material. We've got one called 330 Fast. Ask your distributor about it. They need to know about it. And if it works great for you, then hopefully they're going to start stocking it well for you. Grind and patching. Like I said, this is commonly done. If the job's not real bad, this concrete's in pretty good condition, quite often you can just take and grind down the high spots. Today, of course, you have to have HEPA filters and everything else to keep the silica sand down, but grind down the high spots, float out the rest of the bird baths, and get ready to start setting your tile. But take your straight edge, check all the areas, make sure you get it reasonably flat, otherwise you'll be fighting it the whole installation, guaranteed. Let's talk briefly about self-levelers. As I said, the other flooring industries have been using them forever. Resilient floor covering inside, self-levelers were critical to them, been around forever. They've been around in the tile industry, but really not as common. They're getting more common today. As a matter of fact, quite often they're replacing mortar beds where mortar bed would have been more appropriate. But they're intended to be very viscous, very thin. They pour as like a fairly wet cement, hardened to many as 5,000 psi or higher. Very high compressive strength, very high density. Will work over a variety of different substrates. Most manufacturers have a large variety of different types, and they can go anywhere from just a skim coat to as much as 4 inches, depending on what it is. But I will tell you one thing about self-levelers that I think is commonly misunderstood. A couple things. Number one, they are a very technical mortar. What I mean by that is most of them have a large variety of chemicals in them. I'm talking up to 20. Where a thin set might have 5 or 6. We're talking 20 plus chemicals inside these materials. You do not want to overwater a self-leveler, as an example, because the material that makes it viscous or thin and then sets or gels, you don't want to disperse that too far. It'll take forever for it to set up. They're very technically formulated. So follow the directions, follow the water ratio. If you overwater a self-leveler, what happens is the sand drops out, the cement fines come to the top that expands and contracts at a much different rate than a properly poured self-leveler, and commonly will fail. I've got a weak bond down at the substrate because it's all sand, and I've got a very rich material at the top that wants to expand out. So it's critically important that you put the proper water to powder ratio. The other thing I wanted to mention about self-levelers, we call them self-levelers. Quite often, that's not how they're used. They're used to just get us within our floor tolerance, not to actually level a floor. In other words, make it flatter to accommodate an installation. We'll talk more about that. Some of the different types of levelers out there, there's cement-based, flowable levelers. There are gypsum-based ones as well. Now be careful what you're doing with gypsum if you don't understand it well. Cement and gypsum do not play well together. Typically you build an etronite and can create bond breaks and so on. So gypsum's not as common in our side of the business because most of our adhesives are cementitious, but they're out there. Rapid setting levelers, so if you have to get on the project a little bit quicker, typically you can tile in 3 to 4 hours in most levelers. There's lightweight levelers. We get asked about these all the time in remodels, especially old buildings, and they don't want to put a lot of weight on the top. So a lot of times you get lightweight levelers. Levelers for very thin caps or just a skim coat if you might. We have SLUs or self-levelers for deep pours. We have one that'll go 4 inches just without any additional aggregate or anything like that. So you really have to need that. That's a lot, but we definitely have some for deep pours. Surface preparation can be critically important to self-levelers. There are also ones out there that are shrinkage compensated, and the amount of prep is not quite as high as the ones that are not calcium limonite based. And there are moisture resistant levelers. We commonly use these in go early construction. Sometimes we'll get asked to go in and start leveling a project before the walls are even built. Meaning the outside weather is kept out by walls, but not the interior. Why? Because then they can go in there and actually have one, they can put in moisture mitigation type materials and then put a leveler over the top of them, come in there and drop steel doors, steel frame doors, things like that, and be fairly easy because their substrate's level. It's go early construction, commonly done in hospitals, some schools, etc. All right, we just talked a little bit about this, surface profiling. Some that's not as common to the tile industry as it is to the other flooring is CSPs, or concrete surface profiles. The ICRI, International Concrete Restoration Institute, Repair Institute, has different CSP numbers based on the roughness of the slab. So one that has barely been, just a rough trowel, if you might, is probably a CSP of 1. If it looks like it's been scarified or sandblasted, 2, 3, etc. And so they're all the way up to I think 8 or 10. There's quite a few profiles, but what does it do for the self-leveler? It gives it something to bite to. So if you got a little bit of irregularity in the slab, you put the material over the top, it just kind of locks it in, if you might. Much like if you were putting thin set over an existing old brick, because you're going to set tile over an old brick. You get that keyed into those mortar joints, if you might, that irregularity of that joint being set back a little bit, and so on. You got a heck of a bond because it's mechanically locked in there. Same thing's true here. We want to get a mechanical bond, a real lock into that concrete surface for the self-levelers. Make sure that there are contaminants on the slab that it gets removed. I can't tell you how many levelers I've seen fail because of old adhesive residue. Everything from cut back to just carpet and vinyl adhesives. These materials are very, very strong. They expand and contract in the initial stages a little bit. Again, if they're shrinkage compensated, very minimal amount, but if they're overwatered, they're going to do it a lot and they're going to fail. Mechanical removal is always preferred method. We do not recommend that you go in there with chemicals and break it down. That just penetrates the slab further. So now all of a sudden you might have to remove, instead of what's just on the very top surface, maybe you've allowed it to penetrate as much as 1/8 of an inch. I probably get a project in my office once every 2 weeks. It's like this, where it's penetrated so far they're going to actually have to scarify or remove a layer of the cement. But mechanical removal is preferred. Don't try chemically. Metal lath, depending on the leveler, the manufacturer, they may require that they have metal lath or plastic lath for that matter on all wood substrates. we don't require it. There are substrates, if they're in good condition, so on, that you put a leveler on, a wood one, I mean, and with a good primer and so on, you'll bond extremely well. We've got directions specifically for that. But other people do want a mechanical layer, meaning like metal lath or something like that down. Make sure your deflection criteria is there, that you don't have too much deflection. Make sure it is clean. The key to any leveler is cleanness. Make sure that you get a good bite to that surface if you might. Remove any contaminants like overspray and things like that. Sand sweep, vacuum, sometimes even lightly mop. All right, so in 2021, we put out 2 new industry standards. A10821, which is the installation of a flowable hydraulic cement underlayment, or a self-leveling underlayment, same word, same name if you might. Why do we have flowable hydraulic cement underlayment? Some of the contractors in the group felt that they aren't always actually trying to level a floor, make it perfectly level. They're just trying to flatten it out to get them within tolerance. So they wanted to be able to kind of describe that as well. And flowable hydraulic cement underlayment does do that. So both terms are appropriate, but flowable hydraulic cement underlayment is a newer one, came out with a standard. Then there's also a standard for the material itself, type of PSI strengths, et cetera, that you should have. There's a regular and high performance self-leveler, and again, that's in 118.16. A118.16. Some of the information within those standards, it says regarding substrate flattening, the intended use of flowable hydraulic cement underlayments or self-leveling underlayments is to flatten the substrate to meet tile industry required flatness tolerances, and to help reduce the substrate's contribution to tile lippage. If underlayment is specified for leveling to designated elevations, this intent needs to clearly be expressed in the project specification and in all applicable sections along for elevations and tolerances. In other words, you cannot assume because the self-leveler is specified that it is intended to be perfectly level. That is a different animal. If we have to go in and level a large area, and we do it all the time, truckloads of material, you really have to be very, very cautious in what you're doing. You have to know your area, the floor, where it's out, where it's in. You have to pin it. Commonly, you have to do extensive surveying, in other words, to know where the low spots are, the high spots, so you can easily identify those as you're pouring the leveler. It may require some different prep. It may require a more aggressive CSP. It's a different animal if you want it perfectly level. It can be done, but it's far more time consuming, and the contractor really has to have a lot of experience in getting it perfectly level and know exactly where the irregularities are on the floor. So quite often there's little tabs, if you might, pins that they put out, and they have different heights to them. And where it's out, you know, where it's deep, they'll have a deeper pin, and then of course a little bit another area they might have one that's not quite as shallow. Primers are critically important too. We make a variety of different primers depending on the type of substrate it is, depending on the type of leveler that you're using. We can do everything from steel to copper, plywood, of course, concrete. So there's a large variety of primers out there as well. Some that really work well in low absorption substrates, like epoxy moisture mitigation. Some that won't not work so well on that. They need a bit of absorption, like more of a latex type based one. So pay attention to levelers, critically important as far as the type of substrate you've got, the type of leveler that's going on, how thick it's going, etc. Most levelers require a primer. They can be made without them, but they get very costly and they don't perform that great. When you're priming, it does a couple of things. It isolates the layers and promotes bonding, but more importantly, it kind of slicks out the surface too. So if you're using the proper primer, it will actually help the leveler flow. It slicks it out a bit. So the choice quite often on the type of primer depends on the absorption of the substrate and what it is you're actually trying to achieve. Like they're acrylic-based ones or latex-based ones. Some are diluted, some are not. There are epoxy-based ones. So again, just depends on your project, the substrate, what you're trying to achieve. Take a look at the primers and selection charts for that matter. As mentioned earlier, levelers flow like water. They're thicker than water, of course, but the same principle. If I take an empty bottle, a glass jar for that matter, and I tip the jar, the water stays level. Same thing true here with levelers. They'll only do that for so long as they start to lose their flowing agents, but they will do it. You need to isolate perimeters, columns, any protrusions through the floor. There should be some movement area there. You can put foam around it. You can put, some people use sand, a variety of different things, but allow for that leveler to expand and contract, especially on large pores. It creates a lot of stress within the leveler itself. Perimeters are critically important. Typically, like I said, most people use a foam tape. Real easy. You get the leveler done, come back and just razor cut that right off. And try to identify where you want to start pouring and where to stop pouring, so you can identify the day's work. You don't want to go right in the middle of the next day's work or anything like that. If you can cut it off in the doorway, that's ideal. If you can cut it off within a certain area, that's ideal. So identify where you want to get within that day's work. Maybe sometimes you put the primer down for the next day if you got done a little bit early. Primers do need to cure. If you pour over a primer that the top surface is just, it feels dry, but it's not completely dry all the way down, levelers may tear it off. So you want to make sure that you've got it completely set. Follow the directions. We've got one for non-porous surfaces. It says it needs to cure a minimum of 5 hours in ideal weather conditions. If it's cold out, it may take longer. Almost all these materials are going to take longer to cure if it's cold out. So pay attention to temperatures, high humidity, things like that, and how it may affect your primers. Make sure they're good and set. Variety of different ways to do mixing. You can set up anything from a 2-barrel, 3-barrel mixing tubs to pumping. We do a lot of both. Typically, larger areas are pumped. People that really know what they're doing, and it can really move some material in a day, a phenomenal amount of material in a day. So, but at the same time, with a appropriate crew, a couple people at the mixer, a couple people out there pouring, you can pour a lot of them, but just by barrel mixing as well. As I mentioned earlier, the amount of water that you add to these materials is critically important. You can see on the far left where they used the proper amount of water, then they started increasing it. And if the material changed, that's the same leveler, exact same material, just different water contents. And the far right, you see where all the vinyl is actually washed up into the material and showing it's on the top surface. Now that's a very soft material. You can scratch off with your fingernail and all the way down through it. So really important. Make sure you follow the water ratio. What we typically do is we get a larger pail for mixing 2 or 3 bags in it. We'll take a 1 gallon or 2 gallon bucket, put a hole in it when we have the proper amount of water. So in other words, we get it filled up to 6 quarts, and then put a line on the bucket and go back and drill holes right around that line so you can't overfill it. You can't overwater it. You just dip that into the bucket of water, pull it out, it quits leaking out of the holes. You got the proper amount of water, start mixing. Critically important. Can't stress it enough. This is a very technical material. Always try to work wet edge to wet edge. That's why it's important that you try to figure out your day's work, where you want to start, where you want to stop. Typically, when you're wet edge to wet edge, you might come back over the top of it, the new pour to the old pour, and just lightly strike it with a magnesium striker or something like that, and just blend those edges in just perfect, so it's perfectly flat. But figure out your day's work. It's very important. Porcupine rollers can be helpful. They break the surface tension, allow the material to flow a little bit quicker. Spike shoes are very helpful when walking over an installation, depending on your thicknesses and so on. And gauge rakes can help a lot too. As I mentioned, sometimes you might, we've done projects where they just went in and they did asbestos removal. Now they want to cap it 1/8 of an inch. Well, that's where a gauge rake can really come in helpful. You can set that gauge at 1/8 of an inch, make sure that all the leveler just stays at that thickness. It is not necessarily level. but it is flat and smoothing out that surface. And protect it. These materials are not concrete. They're not, you know, they're cement based, but they're a different density. If exposed to heavy road traffic too early, it can create some ruts in it. Make sure it's protected. And not to mention, you're going to be putting finished materials over it. You don't need overspray from the painter that just finished the drywall when you were gone last night. Try and keep foot traffic off it if you can. Certainly scissor lifts and etc. If you do have to get them on there early, protect them with plywood or something that's appropriate. And try and keep it trades off until it's completely cured. It's an absorbative surface, so it can contaminate fairly easy. Like I said, overspray from the paint, that will do it. Dirt and dust, you don't want the drywaller in there sanding the hell out of stuff the day before you're going to go in there and start installing tile. It's got to be clean. Make sure that it's clean. Follow the technical data sheet of the manufacturer and the product that you're using. Follow it well. Take the time to read through it, please. And certainly the protection area. In summary, larger and bigger tiles, thinner materials as well require flatter substrates. Understand the industry surface substrate tolerances. Very, very important. Again, if you meet those tolerances, your installation should go 100% better, much easier, much faster, more productive. As I said, they've been used in other floor coverings forever. Now they're just going to become more common in tile because of the size and format of tile. Self-leveling can save a lot of time and money on the appropriate project. The type of substrate, environmental conditions, and timing can determine the leveler and the primer that you're going to use. But leveling does require some expertise, some tools and manpower to do it successfully. Without those, you're going to probably have a big failure. So again, make sure you understand what you're trying to achieve, where you need the leveler, where you don't. If you're just trying to cap an area, that's not so bad. Gauge rake it and get out of there. But if you want to make sure that it's perfectly level, that's a different animal. Now you got to have a really good feel of the topography if you might have that concrete substrate you're going to pour into. Man these projects properly. That's really important, especially when you're trying to keep wet edge to wet edge. I'll also mention that for surface preparation for tile and stone, NTCA does a regional training on that, and we've done quite a few of them with them, and they do a great job. So they'll patch out walls and floors and work with these wall render materials as well as mud beds and so on. So they do a great job. Follow up with the NTCA and check out where their regional trainings are going on. With that, I want to thank you, and I'll turn it back over to Jim.
Jim, great information as always. Thank you very much for that. I do want to say one thing that Jim mentioned in here that I think is just critical, and that is that you always follow the manufacturer's recommendation, because what one manufacturer says isn't always the same that another manufacturer will put in their instructions, and it's very important. Follow those instructions to a T and you'll get a great product. So very important. Always want to make sure of that. So Jim, we have a couple questions here if you're ready to answer.
Love it.
All right, here's the first one. One of our attendees says, if I profile my concrete substrate to a CSP 3 or higher before a F8CU, how do I install the primer so that I don't have small puddles of primer that don't like to dry properly?
Depends on the primer. Quite often, they're best applied with a broom, so you can kind of contour to the substrate, and that's one way that really helps a lot. So you can almost sweep it out of it, and then just rinse the broom off well when you're done. But you can apply it by roller if you want, but then come back and broom it real quick, and that'll really help a phenomenal amount, especially with the rougher profiles. I get the question. It's a very, very valid question. And I'll also say, make sure that if you think you might have some deeper areas, that primer is cured before you go pouring on it. Very, very important. But I use a broom.
Yeah, no, I get that, and I agree with that. That's a great answer. I guess all I have left on here for questions, you did such a good job, is people are wanting to receive the program and get a link to the program they can watch later. And like I mentioned, it's on YouTube, and I will make sure, Ralph, that I'm going to put my email on here while Jim's answering this next question. We do have another question here.
Okay.
So Ralph, I'll give you my email. You can send me the request for that. So here we go. Let's see what our next question is. Why is it acceptable to use thin set to apply mesh tape to board seams, but not to float the same seam? Does that make sense?
I think so. So the board manufacturers have their recommendations, and yes, quite commonly they'll have you put on a fiberglass mesh and use thin set to do that. That's how they get their bond. In this case, we're trying to create a bond between the two. But I'm not really sure what you mean by float out the rest of it. But ideally, you're just not, it's, as I said, thin sets are intended to have something go over them. To fill a void, which is what you're doing when you're doing the taping with the fiberglass mesh, is one thing. But to just skim out a large area is not very wise. And there are better products for that.
Timothy, do you want to put any clarification onto your question just to make sure we're answering it correctly?
Yeah, please.
Yeah, I get what you're saying about thin set for putting mesh tape over board seams, but then not to float the same seam. I'm not sure I
typically would float it. We float it flat. So here, let me give you an example. Some of the cement boards have tapered edges. So we would fill that void with thin set, put the mesh onto it, and enough thin set on top of the board so that the mesh grabs, and then come back and float that mesh out till it's completely flat and get rid of the contour. So it is commonly done that way.
Okay, good. All right, Timothy, that should answer that question. Is there any last minute questions? Anybody gonna set anything in here? Otherwise, Jim, as usual, you've done such a great job and given great information that there aren't a lot of questions. And my big thing I want to say again is don't hesitate ever to contact your manufacturer's technical line and ask questions if you're concerned. They're there to help you and take advantage of that. Jim, I want to thank you for a great presentation. All of you in attendance, I want to let you know our next webinar is March 28th. Look for your invite in the next few days. And I hope everybody's having a great spring. Snow is finally starting to melt here in Minnesota, so that's great. I hope to see all of you at coverings, and enjoy, and thank you very much. I appreciate it.
See you all at coverings. Thank you.
Take care. Bye-bye, everyone.